Hello, welcome. Let's try to solve another Leetcode problem. So this problem is going to be 2132, stamping the grid. So we are having this kind of grid, and in some areas it's going to be value 1. So for example, in the first column, all those stamp going to be 1. So this is just like the drawing. It means we cannot make a stamp in this area because it has already been occupied. Now we have some kind of rules or requirements. So cover all the empty cells. We need to meet the condition. Do not cover any of the occupied cells. So for example, this is occupied and we cannot cover them. And we can put as many stamps as we want. So for example, for this one, we have a stamp size of height and width 4 times 3. So we're gonna have 2 stamps, or maybe we're gonna have the same steps again and again, but definitely we can cover all of them. And the fourth stamp is the stamp can overlap with each other. This is okay. And stamps are not allowed to be rotated. Yeah, so this means you cannot rotate the stamp. So for example, if the stamp size is 4 times 3, you cannot rotate it like 3 times 4. Stamps must stay completely inside the grid. Yeah, so this means the stamp must be completely inside. You cannot let it go outside like that. Yeah, you cannot stamp like that. Now let's try to find a way to solve it. So we're going to return true if it is possible to fit the stamp while following the those restrictions. If we cannot, we're going to return a false. Yeah, so this problem, it seems very clear. It's like a 2D grid, because they are giving us a 2D grid and we just need to use stamps, or we can understand it like squares. So if we are giving a 2D grid, just ignore there's some value of 1. We just need to use some kind of fixed rectangles to cover the areas. Just ignore if there's 1 or not. Yeah, we just want to check if we can cover all of them. So what is this problem? Yeah, so this is like a 2D difference array problem. Yeah, because after all the different kind of cover, we just need to check if all those values, we just need to go through row by row, column by column to check the values. If all those values like 1, 2, 3 are more than 0, definitely it is true. But after making the stamp, if there's some value is 0, we're gonna return false. Yeah, but if we ignore there are values of 1, definitely it is possible. Maybe the stamp is the size of the stamp is smaller than the grid. Basically, we can do that. But here we have some values of 1. It means at some other places, if this value is 1, definitely we cannot make a stamp in this 1. Yeah, we have to make the stamp outside it. So this is some tricks we need to deal with. Yeah. Now let's just analyze how can we solve this problem easily. Yeah. Let me make the same drawing. So the first step is we have to check if we can make a stamp or not. But how can we check if, so for example, in this place, can we make a stamp in this place? And how can we do that? So if we can make a stamp, how can we check that is possible? So for example, we're going to use the accumulated sum, the 2D prefix sum. So for example, if this value at here is 4. Yeah, so this 4 means it is the 2D prefix sum. It means all the values from this point, maybe we're going to call it B. All the values from A to B. It is a square. It is a rectangle. So for the rectangle A to B, we're going to have the prefix sum. It is 4. Yeah. But what about this value? So if this value is also 4, this 4 is just outside. It is at this place. Yeah. So if we have another square, another rectangle, this value, the accumulated sum of the 2D prefix sum, this value is also 4. Yeah, I just give an example. Maybe this is a 2 or 4, it doesn't matter. But after we calculating these areas, we have a formula to calculate the accumulated sum in these areas. If these areas, maybe this is 3, it is 2, it doesn't matter. Just for example. Yeah, it is not exactly right, but it is okay. If we can calculate this areas, for example, this area is 0. It means all the values inside the grid in these areas is 0. So this means we can make a stamp. So this is why the 2D prefix sum works, because in this way we can check at any position that if we can make a stamp. Yeah, so this means the first step is that we're gonna use the prefix sum. The second step is that we're gonna use the brute force to check if we can make a stamp in each of the areas. So the condition is that if all the values in these areas, so the size of these areas is the size of the stamp. So if this areas, the accumulated sum value in this areas is 0, and definitely it means we can make a stamp. So after the first and second step, basically we're gonna cover all the areas. And the third step is to check. So for example, if this areas, this value is 0, this is for the grid. So because after stamping, maybe some areas still 0. Yeah. And the accumulated and the overlap size, I mean the overlap size may be 1 or maybe 2 or maybe 0. So what is the overlap size? It means, so for example, this is a square, this is another square. So the overlap, I mean rectangle. So the overlap for this area is 2 because there are two overlap. There are two rectangles covered in this area, so it's going to be 2. So maybe there's another one, so overlap in this area is going to be 3. Yeah, so this is just for the final check. If the value is 0 inside the grid and the overlap time is also 0, so definitely we're going to return a false. If we cannot find a false, finally we're going to return a true. Yeah, I hope you understand all those 3 steps of how to solve the problem. Now let's just get started for the coding part. So as I said, I'm gonna prepare a prefix sum first. Yeah, so let me use R and C represent the row and column of the grid. Yeah, so this is a row and column. Now I want to prepare a prefix array, 2D array. Definitely it's going to be 0. I'm going to prepare a padding of 1 row and 1 column. So it's going to be C+1 for the row in range with R+1. Yeah, so this means I just prepared a padding. Yeah, so this is my grid because for calculating the prefix sum, I just prepared a padding. I mean 1 row and 1 column, 1 row at the left side and 1 row on top and 1 row at the left side. I just prepared a padding. So after the padding, I can easily calculate the prefix sum in the grid areas, in these areas. Yeah. Now I want to calculate it. So for R in range with R+1 and for C in range to C+1. Yeah. And for the 2D prefix sum, we can easily use a formula. So we're gonna use FRC so equal to, yeah, I think normally most of us can remember such kind of a formula, but let me write it first, and after that I'm gonna explain a little bit. So it's gonna be, yeah, let me check. So this value, yeah, the 2D prefix sum is going to be this value minus this value, fr minus 1 and c minus 1, and finally it's going to plus a grid r minus 1 and c minus 1. Yeah, so this is just a 2D prefix sum. Let's just make another drawing maybe. So the drawing is going to be like this, and we are going to calculate the 2D prefix sum for this point. So this is maybe we call it A. Yeah, we're going to calculate the 2D prefix sum in this point. So what is the value? We can make a drawing like this. Yeah, so this is R minus, this is RC minus 1 in these areas. It means the prefix sum in these areas. Another one is RC minus 1. The prefix sum in these areas, but there is overlap. So we're going to minus the overlap, and we also need to plus the value. So that is the grid R minus 1 and C minus 1 in this point. Now we get the prefix sum. Yeah. So After getting the prefix sum, we're gonna prepare a difference array. So the difference array, I'm gonna prepare paddings of row and column, but I'm gonna prepare a padding at the top and bottom, left and right. Yeah. So let me just copy the code in these areas. So, but here the padding column should plus 2 and row plus 2. This is just for easy calculation for the difference array. Yeah, but for the row and column, it's gonna be the same. So far in range r plus 1, and for c in range c plus 1. Now we want to check basically. Let me just copy. Yeah, this is not okay. Yeah, so here, let me just delete these areas maybe. Yeah, I'm gonna check the second point first. So this means for the difference array, let me make another drawing. So definitely we have a padding, row and column. It's going to be like this. Yeah, so this is just the padding. It's going to be 0 in all those areas. And now I want to calculate the 2D difference array, but I want to check the stamp. So maybe at this place, I can make a stamp. So it's going to be like 3 times 4, I mean 3 rows and 4 columns. Maybe. Yeah, it doesn't matter. Maybe it is not exactly like the example, but it doesn't matter. It's just an example. If I want to check if I can make a stamp in these areas. So basically I need to enumerate all the positions like the brute force. I need to use brute force to enumerate all the positions. So for example, next position going to be here, and the next position maybe going to be here. And after the row, the column may be like that. Yeah. So definitely I can enumerate all of them. So let me enumerate all of them first. So I'm gonna enumerate the second point because this is easier. So for x2 in range, so it's gonna be start from the stamp height to, yeah, because I'm gonna check in the row. It's gonna be r plus 1, and for y2 in range, it's gonna be the stamp width with c plus 1. Yeah, so we have to be careful with the calculation because the stamp cannot go outside. So only in this kind of a formula, it is just bounded inside. So for example, the maximum place is gonna be at r. Yeah, because we are using the prefix sum. Normally it should be r minus 1, but now it should be r because we used the prefix sum. We prepared a padding for 1 row and 1 column. So that is why we gonna use this kind of a formula to check the places. Now we can calculate the x1 and y1. So here, so for example, yeah. So for example, maybe let me make another drawing. Yeah, if this is a stamp, yeah. So this point, so it is the x2 and y2, and this point is going to be x1 and y1. So now we are calculating this x1 and y1. So it's going to be the x2 minus the stamp height plus 1, and y2 minus the stamp width plus 1. We have to be careful with such kind of a calculation because if it is wrong, definitely, yeah, we cannot solve the problem. Yeah, so this calculation is like here. So for example, from the beginning, it is the stamp height and width. So in the other example, it's going to be 4 and 3. Yeah, so the x2, 4 minus 4 plus 1, and 3 minus 3 plus 1. Yeah, so this is also plus 1. So this dot gonna be 1 and 1. So this is right. Yeah, because for the 2D difference array, we are just checking this 1 and 1. It's not 0 and 0 because we prepared a padding. So this is just for easy for the calculation. Yeah. Now we want to check if it is possible to make a stamp. Yeah, as we've already finished the 2D prefix sum. Yeah, I'm sorry, here it's gonna be this D difference array. Yeah, because here this F is for the prefix sum 2D prefix sum. This is a 2D difference array. We want to check in the prefix sum. Yeah, so if this F x2 y2 minus f x1 y2 minus 1. I'm not sure, but I will check that later. Maybe this is x2 minus 1 and x1 minus 1 and y2 this value minus this value and plus f r minus x1 minus 1 and y1 minus 1. If this is 0, I'm gonna set the 2D difference array places. Definitely it's gonna be another 4 formulas. Yeah. Now I want to check my prefix sum is right or wrong. So for example, this is my prefix sum. I want to check this areas. I want to check the sum up value of this areas, this rectangle. So because this point is x2 and y2, so definitely I want to minus a value at this area. Yeah. So this area is gonna be for here it's gonna be x1 minus 1 and y2. So this is x1 minus 1 and y2. And for another one, I want to check at this areas, right? Yeah. So it's gonna be at this areas. So the x2 gonna be the same. Yeah, x2 gonna be the same, but it's gonna be y1 minus 1 and x2. Yeah, this means my formula here is not right. So here gonna be x2 and y2 minus 1. Yeah, let me check it again. So this is my rectangle, and this areas, this is x2 with y1 minus 1. Yeah, because this is x2 and this is y1 and this is y1 minus 1. Yeah, so let me correct it, otherwise I'm gonna make a mistake. So now I hope every calculation should be okay, and this basically this area and this dot, this area gonna be y2 x1 minus 1. So x1 minus 1 and y2. Yeah, now I think the formula should be okay. And after finishing the check, if I can make a stamp, so I'm gonna prepare the difference array. Yeah, it's gonna be x1 and y1. It's gonna plus equal to 1. It means I can make a stamp at this place, but it's a 2D difference array. I need to set the x2 plus 1 and y2 plus 1. It's gonna plus equal to 1. Yeah, but before that I need to also check with the drawing, because I cannot remember everything about the formula. Only if I can use a template, but I will not use a template. Yeah, so maybe I have to make a drawing in the whiteboard to calculate it. I mean, you cannot remember everything. I mean, everything is not inside your inside your brain. You cannot think about all the formulas. Why you can remember all the formulas? I think it is not possible. But definitely you can remember some kind of the drawings. So we just make a drawing and find the formula. Yeah, because this is easy to remember maybe, but in between maybe we cannot remember what is inside. Now let's just remember what is the difference array for 2D grid. So here in this area, this is a plus 1. It means to the right side and to the bottom side it's going to be a plus 1, because here is the overlap. Because here at this areas we're going to use a minus 1, and this areas we're going to use a minus 1. So this minus 1 means to the right and bottom, to the right and bottom. Yeah, we're going to have a minus 1 because there's overlap. So this area is going to be a plus 1. So this is why we're going to use x2 plus 1, y2 plus 1, and plus 1. But now we are checking these areas. So for example, let's just check these areas first. So this area is going to be minus 1. So how can we get to the minus 1? So this is x1 and y. So this is x1 and y2. Yeah, so this means it should be x1 and y2 minus 1. So x1 and y2 minus 1. So let me just write it. So it's going to be x1 and y2 minus 1. So here going to be a minus 1. And another one, definitely it's going to be x2 minus 1 and y1. Yeah, let's just have a double check if everything's okay. And for these areas, yeah, definitely I'm checking this position. So for this position, it is the x2. Yeah, it is not minus 1. It is always plus 1. This is x2 plus 1 and y1. Yeah, this means I did some wrong calculation. Now I'm gonna correct it. I think now it should be okay. I mean, basically everything for all those formulas, they are about formulas. We have to make a drawing to check if the formula is right or wrong. Now we finish our first and second step, and finally we just need to return the final result. Yeah, let me just copy some code. So for R in raise R plus 1, for C in raise C plus 1. So this is just for checking the grade with the difference array. So we want to, first of all, we want to check the prefix sum for the difference array. So let me just copy. In these areas, I think it is okay. So I'm going to copy this prefix sum for 2D array formula. I just need to change that to D. So drc going to be dr minus 1, c minus 1, drc minus 1, and minus this dr minus 1, c minus 1. And here we don't need this one, and we just need to use plus equal. So this is going to be the real value in these areas. So what do I mean the real value is how many overlap areas. So for example, this is the step, and this overlap area is going to be 2, and this drc is going to be 2. We are just checking this value. Now we just need to have a final check. So if the grade in this area, because this is the prefix sum, we're going to minus 1 for R minus 1, C minus 1, if this is equal to 0. And also the position, so if this position, the value is 0, and the overlap with the overlap we calculated is drc. So if drc equal to 0, and grade R minus 1, C minus 1 equal to 0. Yeah, this means if this position, there's a value 0, and after stamping, it is still 0. There's no overlap. It means we're going to return a false. It means it is not possible. Let me return a false. Otherwise, we're going to return a true. So this is going to be the entire code. I'm pretty sure, I'm not sure if everything is okay. I have to check. Yeah, because it's all about formulas. You can say how many formulas? 1, 2, and 5. 1, 2, 3, 4, 5, 6, and 7. Basically, we have 7 formulas. If any kind of a formula is wrong, definitely we're gonna get wrong. Now let me just make a running to check. Yeah, it seems that something is wrong. So let me try to debug. Maybe let me just have overall checking if everything is okay. R minus 1 C, RC minus 1, F and grid. This prefix sum should be okay. And let me check about the difference array. So this is going to be the height with R minus 1, and this is going to be the row, and this is going to be the column. Yeah, and x1. x2 minus the height plus 1, y2 minus the width plus 1, and this is the formula with x2 y2 minus x2 y1 minus 1 minus f x1 minus 1 and y2 plus this value if it is equal to 0, and this is the position dr minus 1c, this is equal to 0, and yeah, I cannot find which one is wrong. Maybe I need to print some values to check. So let me print out the F first. Normally this is the prefix sum. So for the first example, yeah, I got some minus value. That is definitely impossible. Normally I should not have the negative values for the prefix sum. Yeah, this is because I forgot to start from 1 to r plus 1 and 1 to c plus 1. And then, because of the Python property, we're gonna calculate some negative values. And after preparing this, it should be okay. Yeah, because we prepared a padding. Now I think the prefix sum has already been fixed. It should be okay. Now I want to check what is wrong with this kind of difference array. So for the difference array, first of all, I want to check if my calculation for x2 and y2 is right or wrong. Definitely I can find some positions. I will to check how many positions. It seems 4 positions. I think this is also okay. Yeah, it should be like 4 positions. This is also okay. Yeah, now I think the problem becomes the formula for the difference array. X1, Y1 gonna be this one. So let me just check the prefix sum. Maybe the calculation for this formula is wrong. So let me make a drawing. Yeah, so this is fx2 and y2. So the minus fx2. So this is x2 y1 minus 1. Yeah, and now I want to calculate this position, and this position gonna be x1 minus 1 with y2. And now I want to check the duplicate. It is here. So it's gonna be plus fx1 minus 1, y1 minus 1. Yeah. So if it is 0, I want to prepare the 2D difference array. Now I want to check a little bit about the 2D difference array. So here is plus 1, so I set the value. It should be dx1 y1, so the plus equal to 1, and here x2 plus 1 and y2 plus 1, here should plus equal to 1, and this areas, so this areas is going to be x1 plus 1, this areas is going to be, I mean this position, this position from this areas is going to be x1 y2 plus 1, so this is x1 y2 plus 1, and about this position, yeah, and about this position is going to be x2 y1 plus 1. Yeah, so at this position it's going to be x2 y1 plus 1, but I did it for x2 plus 1. Definitely it is wrong. Yeah, so it's going to be, because this position is going to be x2, it's going to be x1. So this position is going to be x1 y2 plus 1. Yeah, so this is x1 y2 plus 1, and this position is going to be yeah, I got confused with the grid system. Yeah, so what is this position? So this is x1 y2, and definitely here gonna be x1 y2 plus 1. So this is right. Yeah. So this is x2 y1. So this is x2 y1. It means it is x2 plus 1 and y1. So it is x2 plus 1 and y1. Yeah. And finally here, yeah, this means this is also okay. I mean, the formula should be also okay. Let me just check the difference array. So I'm gonna print out the difference array to check what is the value. Yeah. Yeah, but I get something wrong. I think normally I cannot get. This is not expected. Normally I will not get some negative values. Yeah, because this is just yeah, I can get some negative values because I have a setting of difference array +1 and -1. I can have some negative values. Yeah, I think I need to print out yeah, make the alignment to check if everything is okay. Let me make an alignment like this to check if the difference array is okay. Yeah, because I didn't find any problem with the formula actually. So after making the alignment, definitely, because here I cannot make a stamp. Yeah, and I also prepared a padding. So this is the first column and first row is the padding, and this is 1. I cannot make a stamp, and I'm gonna make a stamp from here. Yeah, because it is a 3 column and 4 rows. Basically, it is in these areas. Yeah. So it seems it is also okay. Yeah, it seems the 2D difference array is also okay. Let me make a comment. Now I want to check these areas. Oh, I found the problem. It is from here. Yeah, because I forgot to prepare a padding. Because for the prefix array we have a padding, but I forget about it. So that is why. So for R in reads, it should be starting from 1 to R minus 1 and 1 to C plus 1. Yeah, you know, I forget about the padding every time for each of the checking. Yeah, but normally I will not forget about it. I don't know why this time I forget about it. Now I think the formula should be okay. Let me just make a running. As you can see now it works. Now let me submit it to check. Yeah, as you can see it works and it's pretty fast. Now let's analyze a little bit about the time complexity. So for the time complexity, we just need to check how many for loops. So there are 2 for loops for here. And for here, 2 for loops, and here also 2 for loops. So the time complexity is going to be m times n. It is 2 times 10 to the power of 5. That is why it is so fast. If you are not using the difference array, definitely you cannot solve the problem, because this problem is specially designed for 2D difference array. Thank you for watching. See you next time.